Hello everyone, my name is Kaan. I'm a second year computer science student. Today I will be making a study about static and kinetic coefficients of friction. So let's introduce our equipment. I have an inclined plane. I have a wooden block. I have a support and two heavy objects to fix our inclination and two rulers to measure distance and a timer while calculating the kinetic coefficient of friction. So let's start with static coefficient of friction. To make this, I will gradually increase the inclination of the plane until the block slides. So let's So when the block slides, I fix the inclination and the angle of the inclined plane. And by measuring the distance to the center of the support and calculating the height of the support, I can calculate the tangent of this angle, and by calculating it, I can calculate the static coefficient of friction. In the second part of the experiment, I will calculate the kinetic coefficient of friction by measuring the time elapsed from the block going from starting point, a fixed starting point, to the end of the inclined plane. So let's start. So, by repeating our calculations, we will minimize the error and finally we can calculate the kinetic coefficient of friction.
To explain the measurements and the foundations further, let's first examine the free body force diagram of the wooden block. There are three essential forces acting on the wooden block, mg, F and M, that are weight, friction and the normal force. In the first part, when the inclination angle theta increases, mg sin theta increases, so the resisting friction force against mg sin theta increases until its maximum value. The block slides just after the static friction reaches its maximum value. The angle providing this maximum static friction is called theta critical. The maximum value of the static friction is static coefficient of friction times n, which is equal to static coefficient of friction times mg cosine theta critical, which is equal to mg sin theta critical. From these equations, it is obtained that the static friction coefficient is equal to tangent theta critical. The average of tangent theta critical is calculated as 0.3876, which is equal to the static coefficient of friction. The corresponding average critical angle is measured as 21.19 in degrees. In the second part, a larger angle than theta critical is used, that is called theta. When the object moves, static friction is replaced by kinetic friction. Since we use a larger angle, mg sin theta is larger than the friction force, that is equal to the kinetic friction coefficient times mg cosine theta. By applying Newton's second law of motion, it can be written that mg sin theta minus kinetic friction is equal to m times a. And by substituting kinetic friction with kinetic friction coefficient times mg cosine theta, it can be obtained that the acceleration is equal to g times sine theta minus kinetic friction coefficient times g cosine theta. And by rearranging these equations, it can be found that kinetic friction coefficient is equal to tangent theta minus a over g times cosine theta. And also, since we release the block from rest, which means that the initial velocity is 0, a can be replaced with 2d over t square. At a known distance, which is equal to 0.9 meters, and a larger angle than theta critical, which is 30 degrees, it can be found that the average time required for the block to move to the bottom of the inclined plane from a fixed start point is 1.4 seconds. And the average acceleration is 1.68 meters over second square. And by combining these, average kinetic friction coefficient is found as 0.359. Measurements are repeated multiple times in both parts to minimize human and equipment errors. It can be visualized that the static friction coefficient is larger than the kinetic friction coefficient. This is a theoretically expected result since it requires more force to start motion than to maintain it. Moreover, it can be seen that there are minor inconsistencies during the measurements of the kinetic friction coefficient. For example, trials 6 and 7 can be taken as outliers in my measurements. However, these errors are balanced by the consistency of the other trials, which show an approximately constant data. In conclusion, this experiment has successfully measured the kinetic and static coefficients of friction and proved the theoretical expectation that static friction coefficient must be larger than the kinetic friction coefficient for the same surface and object.